Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In this episode, we're going to be implementing the Pillbox collider you see on Mario here, and we will be implementing the player controller. So that will be pretty cool. Now, just as a reminder, or I guess sort of I'll show you guys, I've gone ahead and implemented a little bit more of the game, so it's basically complete now. You can go ahead and you can go and get your power-ups and everything, and you can play pretty much like a normal game of Mario. You can go through the pipes now, they all work. There's no coins here because I figure I'll leave that up to you guys. If you really want me to, I can implement them and then we can go over them in the series, but it's simple enough. Fire Mario works and everything too. And then you hit the flagpole and you slide down. He slides down the wrong way and everything, which I realized afterwards, but you know, it's good enough. And then it changes the scene back to the level editor once you finish up. So we've basically got a fully working game. And you'll notice that as I zoom out, you can sort of see the whole level in context, which is pretty cool. So this is what we're working towards, okay? Just another reminder. And we will be implementing the player controller, which is not as easy as you might think. All right, so before we go ahead and actually build Mario, we need to go ahead and add in that Pillbox collider that I showed you. And even more important, I guess, we should very quickly actually set up our physics to support those contact listeners we set up last time, right? So I went about setting up the contact listeners and everything and completely forgot to show you how to actually set it up so that the contact listeners work. It's very simple. I just completely missed that step. So if we go and make a constructor in our physics 2D, you can tell physics or box 2D to call back to your contact listener by just saying, hey, world.setContactListener to a new Jade contact listener, or whatever you called yours. And that's all you need to do. This will basically just set it so that now whenever we get those begin and collision callbacks and all that stuff, it will go through our Jade contact listener like we want it to. With that out of the way though, let's go ahead and go into the Pillbox collider because that is a little bit more complex, but it's still not too bad. So I'm going to go ahead and create a new component here. We will just call this Pillbox collider. And this is going to be exactly that. And I guess this is a good point too. I should probably explain why I have a Pillbox collider. So I initially tried setting up Mario as an actual physics-based solution. I originally coded it so that was using box 2D physics to basically control the player input, but it didn't work out too well. The controls weren't as snappy as I would have liked them to be. Mario didn't really accelerate the way I wanted him to, and I couldn't get it to feel quite right. And I looked it up, and the common theme is basically to use the physics engine to handle collisions and stuff, but you can basically you set the velocity yourself and sort of set the rules of your player control yourself. That way you can get fine-tuned control over it while still having the advantage of the physics engine. Now, of course, not all games do that, but it is a pretty good way to handle this, and it worked so much better for me. And I used a Pillbox collider because as you're sliding over boxes, it's really easy to catch onto one of the boxes on accident. So like if we go back into the scene, we have all these boxes down here, and it's very easy if Mario has a box collider attached to him for it to catch onto one of these corners. And if you switch to a Pillbox collider, that just makes sure that you don't. So it's a good thing to have in an engine, regardless of what you're using it for. And it's not too hard to implement. So the way we're going to implement it is we'll say we have a private transient circle collider, top circle. So this will basically be the top circle in the Pillbox, right? And the Pillbox, I should probably explain this too. A Pillbox collider is basically just it looks like a pill, right? So you can see Mario here, and you can see that Mario sort of has these two circles on here, and there's actually a box in here too, which is a little bit harder to see, but you can see there's a box in between them, and that box sort of represents, if it was to get taller, then the box would basically represent the height of Mario. So that's the Pillbox collider, and that's what we're creating here. So we just need two circles and a box for the center. So let's say private transient circle collider bottom circle equals a new circle collider, and then we'll go ahead and say private transient box collider 2D, and this is our box is a new box 2D collider. Okay, and then we're going to go ahead and say private transient boolean reset fixture next frame, and this is something I added in a little bit later into the game engine. Basically what this means is I had the use case, right? So let me show you exactly why we have this. Basically, when you're Mario, you have a small box collider because you're little Mario, right? But as soon as you hit this mushroom, you grow into a bigger Mario and your hitbox changes. And so I literally have to change the size of the hitbox. But since we're doing that on a collision, you can't just change the size of a hitbox in the middle of a collision, right? So what we have to do is we have to basically cache it and say, okay, at the end of this frame, we want to reset this because we've changed some details about it. And that's basically what this flag is for. And then we'll go ahead and say public float width. So this is the width of it. And I just initialize that to 0.1, which is going to be Mario's like base height, I think. And then we'll say height equals 0.2f. It might not be, it might just be random numbers I chose. And then we'll have public vector 2f offset equals new vector 2f. So that will just be the offset. And the reason I'm not making this extend from component or box something, some collider, I think. Yeah, we have this collider and it has the offset. I got rid of this because basically when you inherit stuff, you can't really expose that in the properties window. So instead of doing this, we can actually do this right now. I'll just move this into the circle collider itself, and then we'll remove it from here. And we'll copy this, paste it into the circle collider itself, because it just makes things so much simpler. And then we're going to do the same thing to our box 2D collider. So we'll say private vector 2f offset equals new vector 2f. And then we'll just copy that function too. And then we're going to get rid of collider, say this extends component now, do the same thing in circle component. And now we can just get rid of collider completely. So if I just delete this, we should be fine. Okay, good. So now these are completely separated from each other, which is good because we can also expose these variables inside the editor like we want to. Okay, then we're gonna go ahead and say override the start method. And on start, we're just gonna say this dot top circle dot game object equals this dot game object. So basically these colliders aren't actually visible in the game engine. They're not like their own individual game objects. They're all sort of a combo. So this Pillbox collider is like a combination collider, and you don't really care about the details of the individual colliders. You just care about these. So we don't really add these to the game engine itself. We just add them to this guy, which makes sure that they're only visible inside of here. They'll say this bottom, and that's also why we have to do this so that we actually assign our references and make sure that they're set inside the middle of the game. And then we'll say this dot box dot game object equals this dot game object. Then we're gonna say recalculate colliders, which is basically just gonna figure out how big to make the circles based on the width and the height, and how big to make the box. Inside of public void recalculate colliders, we're gonna say float circle radius equals width over 4, which should give us half of a half width, which is what we want. And then we're gonna say float box height equals height minus 2 times circle radius. And then we're going to go ahead and say top circle dot set radius, circle radius, bottom circle dot set radius, circle radius, top circle dot set offset. And this is where it gets kind of interesting. So we're going to say set offset, and we need to add that function. So we'll basically go into here and we'll say public void set offset. This will take in a vector 2f new offset, this dot offset dot set new offset. And that should be good. Then we can go back into our Pillbox collider, which I put in the wrong place too. We should put this inside of components. So you can go ahead and move that. That should be fine. Okay, so anyways, we will go ahead and say set offset, and we need new vector 2f. Well, where do we put the circle? What's the offset? Well, the offset is basically just this offset. So we'll get this offset in a new vector, plus 0 plus the box height over 4.0f. So what this is basically saying is we want to move the top circle up half of our, a quarter of our height. That way we make sure that our overall height will be the same, and they should basically align perfectly with the box's edges, okay? That might not make complete sense, but that is what the goal here is. Okay, and then bottom circle is gonna be very similar. We're just gonna set the new offset to new vector 2f offset dot sub 0 box height over 4. So it's mirrored just the other way. And then we're gonna say box dot set half size new vector 2f width over 2, which is just sort of the way our game engine works. And the height should be box height over 2, and that should be good. Then we can just say box dot set offset to this offset, which I believe we have not added there either. So let's go ahead, copy this set offset function, and we'll just copy it into here. Okay, cool. And that should be good for recalculate colliders. Okay. Next, we're just gonna make a couple of getter functions. So I'm just gonna say code generate And then we're gonna say getters, and we want to do these, and that should be good. So we just create some getters for those. And then we're gonna create a function to help us to reset the fixture. So we're gonna call this reset fixture. And we'll basically call this whenever we need to reset the fixtures. And so we'll say if window.getPhysics.isLocked, which we haven't implemented, but is very simple. This basically just means that we can't access the physics right now, so we shouldn't be changing anything. We'll just say reset fixture next frame equals true. So basically, if we're not allowed to touch the physics, we won't. Otherwise, we'll say reset fixture next frame equals false. And then we'll say if GameObject does not equal null, then rigid body 2D RB equals GameObject.getComponent rigid body 2D.class. And then we'll say if RB is not null, then window.getPhysics.reset Pillbox collider, which we don't have yet, but we will add. And we'll give it the rigid body, and we'll give it this. So that's going to be very similar to the other collider function things that we have in the physics engine, and we'll be adding those. Let's go ahead and implement those really quickly. So we'll go into physics 2D. The isLocked one is pretty simple because we're just returning something that's coming from box 2D. So we'll just say isLocked return mworld, or world, I think we called it .isLocked. Okay, that should be good. And then for the reset box 2D collider, I'm going to copy these two functions because it's going to be very similar. And then I'm just going to go ahead and do that. And then we're going to say add Pillbox collider. And then this is going to take in a Pillbox collider instead. And we'll just change that to PB. And then we're going to change this to reset Pillbox collider. That's a Pillbox collider, PB. And so this one is basically just going to say pretty much the exact same thing. And then down here, we're going to say add Pillbox collider. And we're just going to give it PB and reset the mass data. That should be good. Okay, and then inside of Pillbox collider, instead of doing all that stuff, we'll just take all that out. And then we're going to say add box 2D collider, RB, and then we'll say pb.getBox. And then we'll say add circle collider, and we'll say RB, and then pb.getTop circle, and add circle collider, RB, pb.getBottom circle. Okay, and we should be good now. That should add all of them back. So we should be good with everything there. Let's go back to Pillbox collider. All of those errors get removed. Then we're going to go up here. We just want a couple more helper methods. Public void set width. And we obviously want a new value for that width. Then we'll just say this dot width equals new val, and we'll recalculate the colliders, and then we'll just have reset fixture. Okay, and that should be good. And we'll do something very similar for set height. We'll say set height float new val this dot height equals new val. Recalculate the colliders. Since we changed the hitbox, we need to reset our fixture once again. And if needed, this will reset the fixture on the next frame, which should be good. Then we're going to go up here, and we're just going to say at override public void update float delta time. And we'll say if reset fixture next frame, reset fixture. So that's how we keep track of it. We'll just keep trying to reset it until it actually succeeds. And then inside of at override public void editor update float delta time, we're going to say top circle dot editor update dt, bottom circle dot editor update. This way we can just see the green lines being drawn and stuff. If we add debug drawing, which I don't know if we have or not, but we can add that if we really want to. And then we'll say if reset fixture next frame, reset fixture. So we just do the same thing in debug mode. That way it gets set properly every time. Okay, cool. That took a little bit longer than I was expecting, but that is Pillbox colliders. Now we actually want to start implementing our player controller. And in order to do that, we need to create a prefab for Mario. So if we go ahead and go to our prefabs class, we already have one for Mario, but we're going to be adding a lot more. So I just have one animation state here, and I'm not going to spend the time to type out all this stuff because the way we have our animation state set up right now, it works, but it's really hard. It's not hard to code. It's just time consuming. And I am not going to retype all this. So I'm just going to copy all of the state machine stuff, and then I'm going to show you guys what I did just so that you can see that. So basically, I'm just going to replace this right here with all of Mario states. And you'll see why I did not do this in just a second. So basically, this is all the code we need. And also, we need another sprite sheet. So I'm going to go ahead and paste this in. This is basically just the big player sprites. And if we go back to level editor scene real quick, and we'll come back to this, don't worry. We basically want one more sprite sheet in here, level editor scene initializer inside of our load method. Here we go. And I'm just going to add some things. So I'm just going to copy and paste over this too. This is just adding a few more sprite sheets. There is nothing special about this. I'm just loading some other pictures I have, which will also be in the documentation or in the GitHub link if you want to download these images and follow along. And you can even copy this code too if you don't want to type it out. But basically, I've just added a few more sprite sheets. We have one for the turtle, one for big sprites. So that's like Mario when he's 32 by 16 pixels. And then one for all the different pipes and one for special items. So that is that. And then if we go back into prefabs, I have just loaded the big sprites because Mario needs those sprites. And then basically what we've got here is just a bunch of animation. So I've got the run animation, which default frame time is 0.2. And then I just basically select all the sprites that we need for that and then set it looping to true. Then I've got the switch direction is basically when Mario's running and then he changes directions. Idle is just him standing still. Jump is him jumping. Then we have the same thing for his big state, right? So when he's big Mario, okay, same thing. Then we have the same thing for when he's Fire Mario, okay? So just same thing again, which is why I'm not going to go through all this. Okay, then we get the state machine. I add all the states to the state machine, right? So run, idle, switch direction, jump, die. Die is the only other animation frame I had, which is basically just his death animation, which is just a single frame. Then I add all the big animations, and then I add all the fire animations, okay? So if you want to use the state machine, this is how you use it. You just set up the different animations. You add them all to the state machine so that the state machine knows about them. Then you have to add all the transfers, okay? This is where it basically gets pretty complicated, right? So we say we want the default animation to be his idle, right? That's the default animation. Then we add a transfer from when he's running to switch direction on trigger switch direction. We go from running to idle on stop running. We go from running to jumping when you trigger jump. Switch to idle when you say stop running, switch to run when you say start running. So basically we're just going and hooking up all the different animations. Like you go to this when I give you this trigger. And we have to go and then repeat that for all the big directions. Then we have to do that for Fire Mario, basically the same thing. And you'll notice I'm using the same triggers here too. So like jump, jump. That way when we're coding, we just have to say on jump, we just trigger jump. And it doesn't matter what animation Mario is in. He will always go to the correct next animation, which is sort of why this is useful. Then we have a power up animation, which basically just makes sure that he powers up to the appropriate next one. So if he's on Little Mario, he goes to Big Mario. If he's on Big Mario, he goes to Fire Mario, no matter which state he's in. Then we have damage, which basically goes the opposite. If he's big, he goes to little. If he's fire, he goes to big, no matter which animation he's in. And then we have the die animation, which basically just goes from all the animation states to die on trigger die. Okay. And then we add the state machine. So it's a lot of stuff, but it's really, there's nothing complicated, just a lot of code. Next, we want to add a Pillbox collider to him. So we'll say this is a new Pillbox collider. And we're going to say pv.width equals 0.39f. These are the values I found that worked the best for me. And then we'll say 0.31f. Then we're going to say rigid body RB equals a new rigid body because we want to add a rigid body to Mario 2. And we'll say RB.set body type. This could be a dynamic body since Mario will be moving. And then we're going to say RB.set friction. Actually, friction doesn't really matter because we're not going to be using that. So I'm going to ignore that. Continuous collision, though, I'm going to set that to false. I think I have it as true by default, and I guess it should be false by default because Mario is not moving. You only want continuous collision if you're using something that's going to be going at very high speeds, which Mario shouldn't. Then we're going to say set fixed rotation to true. We don't want him to topple over whenever he hits anything. And then we're going to set the mass, which again, since we're going to be handling physics ourselves, sort of, this doesn't really matter too much, but that is what I had it when I was actually using physics. Okay, then we're just going to say add component, RB, add component, PB, and add component, a new player controller. And this is where the fun begins, okay? So we don't have a player controller yet, but we will generate that. And we can just return Mario. So let's go ahead and create a new component. And we're just going to call this player controller. And this is going to be a big class, okay? This is not necessarily the way I would write it if you wanted super clean code, but it works. We need player controller, and I spelled that wrong. That's why it's not showing up. Okay, there we go. So if we run this, we're going to get an error. It's because I haven't copied my new images. So if you're following along with this, make sure to copy the new images that I loaded into your appropriate directory. Okay, now if we run this, we get it opened up successfully. Now, one thing that you'll have to remember is every time you change a prefab, it's not going to update automatically in the game. You'll have to delete whatever objects use that, then re-add them. That's not the best, but it's the only way we can really do that right now. And we got an error, so let's see what this is saying. Okay, this is another good important point that I forgot about. So we get this error, and it looks really weird. It says JSON syntax exception. You can see that it's coming from JSON, and if you were like me, you're probably like, what the heck? What's going wrong? My first thought was, okay, this must be the state machine, because this is the first time I've tried to copy the state machine. And sure enough, it is the state machine. And if you look in the state machine, we actually have this hash map, okay? And we want this hash map to be serialized, but for some reason, JSON doesn't like hash maps with complex objects, like this state trigger that we're using, unless you go into our scene, and then we scroll all the way down to where we serialize things, and we add in this line that says .enable complex map key serialization. I don't know why they don't have this enabled by default, because I think most people probably want this enabled by default, but basically this just says, okay, now you can use it and it won't, break on you. And we just need to make sure to put this everywhere we create a JSON object. This is probably where it'd be nice to have like a global JSON object with our settings that we prefer, but that's some improvement you can make down the road. I think the last place we want to add this is inside the game object, because inside our copy method, yeah, we have this right here too. So I'll add that in there. Then if we go back in, we should be able to, first of all, delete Mario. Then we'll go ahead and add him. And there we go. We click him and we add him in and we get no errors. One other thing, our circles are not drawing, and that's just because we need to add our circles. And he's falling. That's great because he has his box collider, or his colliders. Let's add in debug drawing for the circles just so that we can see those. So let's go to circle collider real quickly. And then we're just going to go ahead and say @override public void editor update float dt, and we're just gonna say vector 2f center equals new vector 2f this dot game object dot position, or dot transform dot position dot add this dot offset. So that's basically where the center is, and then we're just gonna say debug draw dot add circle and center this dot radius. Okay, that way we can actually see what we are doing. And we should be able to run this, and now we should see Mario actually has those circles. There we go. Yep, so Mario's got the circles. He is working all right. We don't have any box colliders on these boxes though, so that would be useful. So let's go back into our level editor scene initializer. And the way I did this was basically just by modifying this loop where we can click to get new items. So be prepared, because I just sort of went through the sprite sheet and found the sprites I wanted to have box colliders and manually did stuff to make it work. So instead of going, well, okay, yeah. So right here, I basically just said if I equals 34, continue. So this is a sprite I don't want to have a box collider. And I say if I is greater than or equal to 38 and I is less than 61, continue. So I'm basically just skipping all the sprites that I don't want to have box colliders. Then what we're going to do is we're just going to say right here, when we create the game object, we will say rigid body 2D RB equals new rigid body. And we're just going to say rb.setBodyType, and then we're going to go ahead and say bodyType.static, because these are going to be immovable objects and static is the appropriate thing in that case. And we'll say object.addComponent rb, and then we're going to say box2D collider b2d equals new box2D collider. And I've also made sure that all of these blocks, I believe, are the grid width, so we can safely say set the half size to 0.25f, 0.25f, and that should be good. And I'm just going to add that to the object as well, so we'll add b2d. And we're also going to add a new component, which is ground. And that way we also know that these are all ground components. We'll just go ahead and create a new class in here, call it ground. That is good. Extends component, and this is basically just going to be a data only thing. It's not even going to have data. It's just sort of a tag. It's like, hey, this is ground. Okay, that's all we're going to use it for. So if we go back into level editor scene initializer, you can see that we're good here. This needs to be a vector 2f. And then for breakable bricks, because those are a thing too, we'll say if I equals 12, which is the one that I wanted to be breakable brick. We'll say object.addComponent new breakable brick, which we don't have yet, and I'm not going to be doing in this episode anyway, so we'll just comment that out for now. Okay, so basically now if I go ahead and I'm gonna delete all of these, and then if we click it now and we add it, you can see it's got green because we are adding box colliders too. So now if we run this, Mario shouldn't fall through them. And that makes sense. I was just not thinking, and we never added in a case to handle Pillbox colliders inside of our physics. So if you go into physics 2D here inside of our add game object method, we just basically need to make sure we actually add the Pillbox collider if you have it. So say if Pillbox collider equals go.getComponent, Pillbox collider.class does not equal null, then we'll say add Pillbox collider, RB Pillbox collider. Hopefully this should take care of it. I'm not actually sure. I put in another Mario because I was testing some things. So now if we play it, okay, yeah, now he hits the ground and he actually stays on the ground. Cool. So that's good. Let's make him move. So let's go into player controller and actually start implementing a player controller, which, like I said just a second ago, is a lot harder than you might think it is to make it feel right. This is going to be a giant class too. I'm just going to say that up front. So I'm going to say we're going to have a float walk speed, and this is his walk speed initially, and then public float jump boost, or basically this isn't his speed, but like the force we add every frame. Jump boost will be 1.0, public float jump impulse, and these are just the values I found that work the best. It's 3.0, and then public float slow down force equals 0.05F, which is sort of like friction, the way I did it. And then this is where we sort of have to implement our own physics a little bit. So we'll say terminal velocity, which is the fastest he can go, is a new vector 2F. 2.1F, 3.1F, which are good values that I found. And then we'll say private, or we'll say public transient Boolean on ground equals false initially, because we don't know if he's on ground or not. And then we're going to say private transient float ground debounce. So this is where it's just a massive amount of variables that we need to keep track of a bunch of different state about the player. So we have a ground debounce, which basically says this is how much time you have that you can hold the space button after you've pressed it. Because otherwise we don't want you pressing the space bar anymore. That way you can have a variable length jump, okay? And then we're going to say private transient float ground debounce time, which is basically like how much time you get each time, which is like 0.1 seconds for jump. Then we're going to say private transient rigid body 2D, RB. So this is basically the rigid body attached to this game object. We also need the state machines that we can switch states. We also want to have a float big jump boost factor. So basically when you switch sizes, Mario needs to jump a little bit higher for whatever reason. So when he's bigger, it's because his mass data changes. I was using this for the initial physics. We might actually not need this anymore, but I'm keeping it here because I have it. And then we also need the player width, which I'm going to say is 0.25F. And then we also need the jump time. Okay, so this is basically how long we've been, how long we have left to hold the spacebar. So actually, ground debounce, I was a little bit wrong. So ground debounce is basically if you run off a block, how much longer do you have to hold it? So it's like a little bit of a grace period. So if I pull this back up again, you'll notice that I can run off the edge of a block and I can still jump off of it if I don't die. So if I go ahead, that lag is messing me up. Okay. So if I jump up here or up here, I can jump, and then as I am on the edge of the block, I have 0.1 seconds to basically still jump. Okay, you see I just ran off the edge there and I was still able to jump. So that's what the ground debounce time is. It's basically saying I have 0.1 seconds to basically press jump key, which gives me a little bit more leeway, and it's noticeable, trust me. And then jump time is basically if I'm pressing and holding spacebar, how long have I been holding it? That way we can adjust it for a variable length jump. Then we're going to have a private transient vector 2F acceleration, okay? And we're going to do this, and then we're going to say private transient vector 2F velocity equals a new vector 2F. Then we're going to say private transient boolean is dead. And we're not going to be implementing all this today. These are just so that we have them later. And then private transient int enemy bounce equals 0. That's basically when you're jumping off an enemy. And that is all I will have for now. Okay. So then we're going to do public void start. So on start, we want to make sure we get a hold of the rigid body attached to our game object. So we'll say get component rigid body class. We also want state machine equals game object dot get component state machine dot class. We also want our to set our gravity scale. So we'll say rb dot set gravity scale, which we haven't made. So we'll make that in just a second to 0.0f. Let's go ahead and implement that real quick. So if we just go into rigid body, wait, we do have this. Oh, I imported the wrong rigid body again. Okay, so get rid of that. And then I'll hit Alt Enter and import it from the correct package. There we go. So then we can do that. This should be state machine.class. And we're setting the gravity scale to 0 here just because we don't want to be letting Box2D. The Box2D is not going to control our physics. We are controlling the velocities ourselves. That way we can get fine-tuned controls over how it feels. Then we're going to have our update method. So let's start with the simplest thing, walking, right? We want him to walk. So if key listener dot is key pressed, glfw key right, or key listener dot is key pressed, glfw key D. So if they're pressing the right arrow key or D, we're going to say this dot game object dot transform dot scale dot x equals player width. So basically we're just going to make sure that we're facing in the right direction. We're going to say this dot acceleration dot x equals walk speed. So I guess that should be walk acceleration. And we're going to say if this dot velocity dot x is less than 0. So if we're moving to the left and they're pressing the right key, then we should play the switch direction. So we're going to say trigger switch direction, which should basically make Mario look like he's trying to turn back to stop himself. And we'll say this dot velocity dot x plus equals slowdown force, which will basically make us slow down in a linear sort of way. And then we'll say otherwise, we'll say state machine dot trigger start running. And we're going to copy this because it's essentially the same, except if we're pressing the left key. So we'll say glfw key left, or if we're pressing the A key. So key A. And if that's true, we want to set our scale to negative player width so that he's facing to the left. We want to set our speed to negative speed. And then we want to check and see if the speed is greater than 0. So if he's going right and we want to slow and he's trying to slow down, we're going to subtract the slowdown force so he slows down linearly. We're going to switch direction. Otherwise, we will trigger state machine. So if we run this as it is now, we should be able to run right and left. Almost. We're very close. You can see that he's sort of moving directions. He's changing, but he's not moving because we're not actually setting the velocity ourselves yet. So the last thing we need to do is basically tell Box2D, hey, this is the velocity we're running at. So we can say this dot velocity dot x plus equals this dot acceleration dot x times dt. This dot velocity dot y plus equals this dot acceleration dot y times dt. So we basically set both of those, and then we'll say this dot velocity dot x equals math dot max math dot min. This dot velocity dot x, this dot terminal velocity, and then I think negative this dot terminal velocity dot x. This should be dot x as well. So basically what we're doing is we're just saying use, this is a clamp function. We're basically saying use x or clamp it to the negative terminal velocity or the positive, whichever it's in that range. That way we don't ever go above our terminal velocity, which is how terminal velocity works. So we'll do the same thing for y. We'll say this dot velocity dot y, this dot terminal velocity dot y, negative this dot terminal velocity dot y. Okay, so that should ensure that our velocities get set appropriately. That will add to our velocity, but we still haven't told Box2D about that, so we need to say this dot rb dot set velocity, this dot velocity, and this dot rb dot set angular velocity to 0. That way we just aren't twisting or doing anything weird like that. So if we do this, we should be able to run to the right, to the left. He's not slowing down because we haven't added friction, but you can see that it works pretty good. He's also not animating correctly, so we'll have to figure out what's wrong with that. And he is also not falling. So we'll just say for now, this .acceleration.y equals window.getPhysics.getGravity, which will add .y times 0.7f. So I'm basically just going to use box 2D's gravity, 70% of box 2D's gravity, which felt pretty good to me. So we'll just go into physics real quickly, and then we'll add in public vector 2f get gravity, return this .world.m or get gravity, and we just want to convert this to a vector 2f. So we'll say new vector 2f. We'll say .x and then world.getGravity.y. Okay, and I'll remove this here. Go back to player controller. So that should at least make sure that we're falling, but we're not actually going to stop. So yeah, because if we do this, we're just going to, actually we might stop. So if we do this, okay, yeah, so the ground still stops us, which is good. You'll see it's a little bumpy because we're basically getting hit into the ground. What we want to do ideally is if we're hitting the ground, set the acceleration to 0 so that we kind of glide across it instead of hitting it and sort of encountering that force. So you can see that even though we're implementing these velocities and stuff, Box 2D is still doing a lot for us because it's handling those collisions, which would be super hard if we weren't using it. Oh, and you know why the state machine trigger isn't working? It's because I implemented this kind of stupidly too. So I saw this and didn't even faze me. Like IntelliJ is warning me about something here. It says list animation state may not contain objects of type string. So what this is telling me is, hey, you're using this index of function, but this isn't actually going to get you what you want. So instead of doing that, we're going to say state index equals state index of, and then I'm going to do instead of this, that. So we're basically going to create this function that sort of does this for us, right? And so I'll go ahead and say implement. I'll say create method, and this is going to return an int, and it's going to take in a string. So yeah, that's good for me. Just let IntelliJ do that. And what we're going to do in here is we're just going to say int index equals 0 for animation state, state and states. We're basically going to look for the state machine matching this S, which is really the state title. So we're just going to find the one that matches that. We'll say if state.title.equals state title, return index, and then we'll do index plus plus here. Otherwise, return -1. So we basically just loop through, find the correct one, and then return that correct one. So now, if we run this, we should see him switch states. Yeah, okay, there we go. So now we get Mario, and you'll see that he goes into the switch direction mode when we're switching directions, which is cool, right? We want him to basically say, okay, I'm moving, but I'm turning around, so I need to do this little animation. So that's good. We want to be able to slow down, though. Right now, Mario doesn't have any friction, and that's not good. So let's go back into player controller and let's add friction. Okay, so we check if it's right or if we're pressing the left key. Otherwise, if we're not pressing either of these keys, we'll say this.acceleration.x equals 0. And then we'll say if this.velocity.x is greater than 0. So if we're going to the right, we can say this.velocity.x equals math.max 0, this.velocity.x minus slowdown force. So basically, we're going to say, hey, slow down until we hit 0 linearly using the slowdown force. Otherwise, if this.velocity.x is greater than or less than 0, we basically want to do this same thing, except we want to do the minimum of velocity.x 0 and plus. And then right here we can say if this.velocity.x equals 0, this.stateMachine.trigger stop running. So basically, if we have stopped, we will stop running. So now if we run this, we should have a sort of friction. And if we run to the right, he runs, and then once we stop running, we stop animating too, and then we can go move ourselves. And this is pretty good, right? This is an okay start to a player controller. This episode has gone on for way, way too long though. Maybe not for you guys. Maybe it's only like 40 minutes, but it's been like an hour for me. So that's the magic of editing. But anyways, I feel like this is a pretty good start. In the next episode, what we're going to do is we're going to implement a ground checker. So basically, Mario will shoot a couple raycasts out to see if he's standing on ground. If he is, that will allow us to jump, and then we'll implement that variable length jump. And I don't know, maybe we'll start implementing like the blocks and stuff. We will see how far we get. That is it for this tutorial. I hope you liked it. If you did, please hit like and subscribe, and I'll see you in the next one. Thanks.